Hello.
Hello.
All right, what do I want to open up here? This thing. By the way, you can see on my screen I have a grades Excel sheet. The grades that you get on Canvas. I always get students freaking out because Canvas is telling them they're getting a B when they think they should get an A or something. Don't listen to Canvas. The scores that you get are correct. Just add them all up, and you know, if you're above 900, you got an A. If you're above 800, you get a B. An actual better way to do that is keep track of the points that you've missed. If you miss 100 points, you drop a letter grade. Okay, so Fridays are devoted to project talk. I posted in, this thing's always in the wrong place. In the modules, I posted under M99, module 99, the project, this writing tips and expectations. So we'll go through these slides in a minute. A short article about plagiarism, and then I have a bunch of examples of previous student work that I've marked good, average, and bad, I think. And in there I included a graduate research proposal to show you that it's not just undergrads who can write awfully. Graduate students have the same problem. It takes a little while to become really adept, at writing. Let's go here and let's go here. Okay, so let's walk through these notes. The expectation is that you're going to be working towards professional writing. And you know how you get to be a good writer? You write every day. You know how you get to be a good programmer? You program every day. So practice, practice, practice. The basic idea here is that technical writing is about clarity and accuracy. It's not about creating a beautiful flowing narrative. It's not about engaging your reader. It's not about producing plot twists, surprise endings, you know, nothing like that. So there's a different skill set or a different part of your brain that gets engaged when you're doing technical writing as opposed to creative writing. The idea here is to try to frame things in such a way that you're promoting clarity, you're reducing ambiguity. Ask yourself questions and have others read these things and ask questions. Ideally, your writing will answer all the questions that a potential reader would have. You want to be concise and precise and consistent. So what do I mean by that? Concise means as few words as possible. As a general rule, the fewer number of words, the better, as long as meaning is not compromised, as long as there's no loss of information. If you can say something in 5 words, and you can say the same thing in 10 words, pick the 5 word, as long as you're convinced that the amount of information in those 2 sentences are the same. And after a while, you learn to eliminate kind of filler phrases, you know, the kind of things that we put in when we're talking more naturally that just don't need to be there. Precision is about avoiding subjective terms, good, bad. The interface for the user should be good. I don't know what good is. I don't know how to measure it. And your good and my good are probably different. So those kinds of terms aren't that helpful. You want to use terms that are measurable whenever you can. And then you actually, when it's appropriate, you want to include the measurement. And consistent. Once you provide a definition for a term, and generally, you know, as technical people, we deal with jargon quite often. You'll want to define what the jargon terms are. Don't assume that everybody knows what these things are. Don't tell me you're going to do an RPG because I don't know if you're going to make a role-playing game or a rocket-propelled grenade. So you have to define all these things. And then once you've defined them, be consistent. Use them the same all the time. If you define something as a RPG, call it an RPG every single time. And this is a difference from what you've heard in a creative writing class. In a creative writing class, they say, don't be repetitious. You bore the reader will lose interest. Find different words for the same thing. And here it's the exact opposite, which makes it easier because basically it's about, hey, define the terms and then use the terms. When you really get technical writing, it becomes pretty easy. Sometimes individual phrases get difficult, but the overall process is straightforward. How much writing should you do? There's no minimum requirements in this class. You know, a lot of times in K through 12 school, you have to do a 5-page report. And what do? You end up putting in extra words and filler words and saying things in the longest possible way just to get to 5,000 words. This is the opposite. You just want to put just as many words in as it needs. If you can describe in the project P2 deliverable, you're going to describe your project functionally. You're going to say what it does. You're not going to say what the design is. You're not going to say how the software is built. You're just going to say what the user experiences are. And if you can do that in a paragraph, do it in a paragraph. I doubt you can, but if you can, that's as long as it needs to be. Historically, these things are about, if they're under a page long, I usually find holes in them. But I'd say somewhere around a page to 2 pages, somewhere in there would be a good length to shoot for. There's no minimum, no maximum. If it takes you 100 pages to write your project description, then it's 100 pages. But I suspect if your project is that complex, I'm going to discourage you right off the bat from doing it. That's too much work for one person, one semester, one class. So once you really get it, that all you're doing is describing something and not writing in an interesting fashion, life gets a lot easier. I had a student a few years ago, oh, I'm having trouble writing my report, I can't make it interesting. And my response was, not your job. You know, good for you. You don't have to worry about that. Not your job. If people need to know the information that's in your document, it will be of interest to them. And for other people, they're not your audience. Okay, clarity. Use the terms defined, use them consistently. And again, definitions are critical here. So, I guess I should have put this in there. When you're using acronyms, every acronym needs to be defined upon first use. And that's true all the time. I've written reports for the FAA, and I've written them with teams of people. Some of the people on the team were hired by the FAA. They worked for the FAA. And the report was going to the FAA. They were the customer. And the very first time FAA shows up, spell it out, Federal Aviation Authority, parentheses, FAA. So do that every single time. Every acronym you use needs defined upon first use. If you're going to use a term, define it. And if you can define it as clearly as possible, which usually means mathematically, which usually means a formula, that's the best. If you can come up with a formula for something, that's terrific. So you'll notice in homework 2, I have you do the volume of a box, and I gave you the formula for the volume of a box so that there would be clarity there, so that we'd all use the same formula. Now in that example, it wasn't that critical other than as an example that you should define these things. But in the real world, it matters. In the real world, if you're going to talk about the volume of a box, people start asking questions like, well, do you mean the external volume of the box? Or do you mean the internal volume of the box? And they can be very different things. If you've got a big shipping container, then the walls of that shipping container are 4 inches thick. The internal volume is significantly different from the external volume. And if you think you're talking about one and your customer is talking about the other, there may be some nasty surprises when the boxes get delivered. Be as precise as you can. Now the opposite of that, don't be vague. Don't be vague. Don't use squishy words like very or a lot. The software will perform analysis of the stock market taking into account many factors. That sentence told me nothing. because I don't know how many is, and I don't even know what the factors are. If you're doing a stock market analysis and you're going to base it on some factors, then you should say based on 6 factors. And here are the factors, 1, 2, 3, 4, 5, 6, probably defined mathematically in that case. GUI is designed for easy understanding. This is actually a tough one to get away from. Everyone wants to have an intuitive GUI, a GUI that's easy to navigate. These are common phrases. They're actually used in production software. They're awfully hard to measure. Typically in a production software, they actually hand the test product to people and say, here, use this and tell us what feels good. Tell us what seems to work and what doesn't. But as a goal for your project, you're setting yourself up with an unmeasurable goal. Don't use words like very, don't use words like a lot. These are not concrete terms. I don't know what a lot is. And that will be my comment to you, in addition to the points that I take off. I don't know what a lot is, -2 points. And then look for the unneeded words. This is actually the hardest part, I think. You want to be as concise as possible. As a general rule, the fewer number of words, the better, as long as you haven't lost informational content. So this project could be considered a simulation of market conditions. This project simulates market conditions. I actually had a student do that. He did a project. It was a great project. He actually got it published in a IEEE conference. And he said this project could be considered a simulation. No, it's a simulation. If you're doing lists of things, if you find that you're writing text and your text is lists of things, for example, some people are going to do some kind of a D&D character generator or something like that, and this thing can handle, and they go through the races and they go through the character classes and they go, put it in a table, put it in a bulleted list. Don't put it in paragraph form. Now, I don't know how many of you guys have tried to read paragraphs in lists, you know, that just have lists of items. But it's awfully hard to do. But a bulleted list or a table that just lists these things, it's awfully easy. When you put a table or an image in, reference it, always reference it inside the document somewhere. The characters that can be generated by this software are presented in table 1, and then table 1 has, you know, orcs and elves and healers and clerics and whatever. Don't use personal pronouns. I'm using personal pronouns all over the place in these slides, and that's okay because this is not technical writing, this is informational writing. In technical writing, don't use personal pronouns. One guide you can do, if you still have your user manual for your phone or your television or for some product, look at the user manual and look at the style in which they write. And they hopefully never say you or I or we, that kind of thing. That's for more informal writing. In magazine articles, you'll see people using I's and we's and you's, but in technical writing, you don't see it. It used to be 100% forbidden. And over the past 10 years or so, I've seen some personal pronouns creeping in. So the normal way people would say things, say in a journal paper or a conference paper, if people had done previous work and now they're building on it, they would say the authors previously considered da 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 da. And now every now and then I'm seeing we or our team previously considered da 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 da. I'm not a fan. I don't like that. I'm more of a traditionalist. Go with the authors. So instead of my project, it's the project. Instead of I will, the software will, the author will, the project developer will. Instead of the buttons on the GUI will let you do something. No, it lets the user do something, or the player if you're doing a game. So you want to take away personal pronouns. And again, this is the opposite of creative writing, right? Technical writing actually employs passive text. passive voice a fair amount, and it's a positive thing, not a negative thing. Formulas, yes, please. If you are doing anything that's a physical simulation, you almost certainly are basing it on formulas. Include them. How much better defined can a term get than if it has a formulaic mathematical definition? If you are doing, okay, let's say you're doing some kind of a role-playing game. And you're saying that, okay, this it's a run from the zombies game, and I have two kinds of zombies, and zombie 1 does this much damage, and zombie 2 does that much damage. Why not a formula? Here's the formula in which the player receives damage, or here's the formula in which attacks are carried out. If you're doing the sheep-sheepdog game, and the sheep speed is some function of the proximity of the dog, why not a formula? So if you use them, use them. Now, if you're just completely making them up, like you're making up your own game, you can just make them up and that's okay. If you're using a formula that's established elsewhere, you're using some kind of a market-based evaluation for stock options, or you're doing some kind of a value of real estate, or you're doing some kind of physics, then those formulas are accepted formulas in that field, and you should put in a reference and cite the authors, cite where you got them. And this can be done even for, F equals MA. It doesn't hurt to cite that. Everybody knows F equals MA, except the people who don't. So it doesn't hurt to cite that. Not all projects will need them, but most will. And I will encourage you as you're writing to include that stuff. References and citations. This is where people get bit quite a bit. So let's talk about that. So virtually everyone will have at least one reference. There's no minimum here. Again, the right amount is what you need. That's the right amount. So there's no minimum. It's not like you have to have 3 references or anything like that. Let me clarify what I mean between a reference and a citation. A reference is the naming of the document that you are referring to. So, and I have a references section at the end of the document. So every document, external document that you're going to reference, you put in the reference section. But then you need to cite to those documents. And citing a document is when somewhere in your text, you referred to something that document had, and you put some kind of a mark there to say, this is where that information came from. In tech writing class, College of Arts and Sciences, they teach you APA style. The style generally depends on what community you're in. So APA style is widely used in the medical field, and the APA, I believe, is American Psychiatry Association. I'm not sure, but I believe. And so they use author year. That's just what they use. In the engineering community, we tend not to do that. In the engineering community, we tend to list all of our references by number at the bottom of the document, and then we just refer to the number. So if reference number 3 was the one that I'm citing right now, I would put blah, 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 factoid, square bracket 3, meaning this is reference, this is item number 3. A lot of people like to do games in this class, and games that are based on published commercial games. And you absolutely need to reference the game that you are, the commercial game. Particularly if you're actually saying, hey, this project, right? The project is a role-playing game based on Zelda, based on Mario Kart, based on whatever. That's a trademark name, and you need to acknowledge that. So acknowledge the trademark and acknowledge who owns it. Acknowledge the corporation. It can be hard sometimes to find the correct citation, but there really are books out there on the history of video games. There really are books and articles that you can cite that talk about those things. The companies themselves produce annual reports and things like that you can cite. So that's the difference between a reference and a citation. And again, almost everybody, if you're doing a game and you refer to any other game that's out there, by all means, credit those people. When do you need a citation? This is something that it takes, can take time to get used to. Every time you make a claim. Now, having said that, almost every sentence you write is going to make a claim. If it didn't, you wouldn't put the sentence in there. So imagine in a paragraph of 8 sentences, you might have 6 citations because every sentence is making a claim. You can test this theory. Do I need a citation or not? Read the sentence and ask yourself, is it making a claim? If someone else read this and they were really skeptical people, would they say prove it after this sentence, right? So you read the sentence, prove it. Oh, okay, how do you prove it? Citation. It's really easy to sneak in claims without realizing it until you become aware of it. And then you get this, oh my God, I have to write a citation for every sentence. That's right. Yeah, now you're getting it. So be aware that there's a lot of citations. Now, you don't have to write citations when you start describing the functionality of your project. That's your work. That's not somebody else's work. You're creating that. So when you're describing, okay, the project will do this, and the project will do that, and the project will do this, and the project will do that, that's stuff that you're setting up as a goal. Now, if it's the project will do this and it follows this formula, then you might need a citation for the formula. If you say the project will do this in a similar way to was done that the Mario Brothers game did, well, now you've brought the Mario Brothers into it, so you have to cite that. So typically your citations will be in the first part of your description of your project, where you're describing the background stuff. Hey, this is in general what it's about. And as you go through the project description more, then you're going to talk about specifics that you created. There will be less citations there. Every claim requires a citation. And then lastly, plagiarism. My experience when students plagiarize code is that they're running late in the semester, they're overwhelmed, they panic, and they find something online and turn it in. Copying code without referencing the source is plagiarism. Copying code and changing the attribute names or changing the variable names or changing the method names is plagiarism. Except it makes it worse in the sense that covering up the crime is kind of evidence of guilt, knowledge of guilt, right? So when I see students do that, then it's more. It just seems like it's a worse form of plagiarism somehow to me. Copying things and then just taking the methods and moving them around, plagiarism. And yes, I've seen all of these things. What's not plagiarism in terms of code? Some of you might need to get products that are already out there, or APIs that are already out there, or even Java code that's already out there to work as part of your project. And it's not the core part of your project, but maybe if you want to work with Excel files, I believe you need to import some special Java files to interface with Excel. At least one person in this class is going to do something with an external system and they need an API. All of that is great and all of that is fine. You absolutely need to cite and acknowledge the original creators of the software. That's not a problem. If you have any confusion about that for your own project, obviously send me a message, ask me, tell me what you want to do, and then we'll make sure that what you're doing is on the up and up. There is a lot of freely available software where it is correct to use it as long as you acknowledge that you did not create the software and someone else did, and here's where you got it, and it's only an incidental part of your project that was needed. The same goes for if you're asking for help from people and you're working out a particular class. If there was a significant amount of work or design that was done, say, by Dean or Robert Apelian or Michael or myself, put that in the comment block. Author, you. Co-author, credit them. They helped create the work. So in code, I think I think that's fairly clear. What confuses students, I think, in text is how easy it is to plagiarize. It's deceptively easy. So in text, you're reading an article online, you need to use only one thing that they said, you cut and paste a sentence from that article, you don't put it in quotations, you don't cite them, that's plagiarism. You don't put it in quotations and you do cite them, it's still plagiarism. You put it in quotes and cite them, no, it's not. So why is it, if you're citing them, even though it's not in quotes, you're citing them, why is that plagiarism? Because what you're supposed to be doing is taking their idea, not their words, their idea, and using their idea in a way that makes sense for your project. So in other words, you're putting your spin on their idea. If you're using their words, you're using their words, and that's not allowed. You have to come up with your own words to express the idea in the context of your project. Even using, read that article that I that short article that I posted online, and it shows you how easy it is. And you'll hear, you know, if you keep your ears open, you know, you'll hear so-and-so got in trouble for plagiarism. I mean, you know, people that are on television personalities and people who are on news teams, or people who are authors got hit with plagiarism, and it's almost always the same. It's a small portion of work that was eerily similar to another person's small portion of their work. It doesn't take much. So when I find those, you know, in the text, as a general rule, I just take off some points and require that you fix it before the next submission. I'm going to pause here for questions while I'm getting my next set of files up. Well, you know what they say, the biggest illusion about a communication is that it has been achieved. So I'm glad to hear that things sound clear. That's good. Okay, so the project deliverables, let's go through, let me do the overview again. So the project one is due tonight, that's the proposal. Everybody, I think everybody who had something turned in on Wednesday, I was able to get feedback to. By all means, if I gave you feedback, you are certainly allowed to modify your document and upload it. Whatever's there at midnight tonight is what gets graded. If you want to, you know, if you still want to do some wordsmithing now, even though you've already turned it in, I'm going to wait till midnight, and nothing will get graded till after that. And whatever's there at midnight is what gets graded. Now, from P1 to P2, we've got a couple of weeks. And let me just walk through and remind you what those are. P2 is basically where you are describing what you want the project to do functionally. So it's the project description is the big part of that. Now there's a couple of small parts, but that's the big goal, is the project description. You are not saying how it's going to happen. Try not to embed the design in the product description, because sometimes you'll find out that that design can't work. And then you're really screwed because you designed yourself into a corner. So try to keep your product description as free from design as possible. It's tough when you're talking about a GUI, because you're going to say, oh, I'll have a button to do this, I'll have a button to do that. Actually, you would say the GUI has a button to do this, the GUI has a button to do that. And then when you go to design it, it might be that a button was the exact wrong thing to pick. It should have been a slider bar, or it should have been a drop-down menu, or it should have been in a text field. So you can get away from that by saying the GUI will have a mechanism to select, right? Now you're not designed into a corner, and you can pick what you need to during the design phase. So the P2 deliverable is all about describing what the program can and cannot do. And then the P3 deliverable, which is way down here, and you'll notice there's a fair amount of time there. There's a reason for that. That's because that's when you are actually designing how the program does it. So the P2 is what is the program doing, and the P3 is how is it doing it. Now you're talking about software design. Still no coding, software design. And then you do coding in 4 short bursts that are called sprints. And I will encourage you throughout the semester to basically don't do any coding until your design is good. And so the P4 is about a week and a half or so out, P5 another week and a half or so out, P6 another week and a half or so out, P7, same thing. So those are short time frames, and they're called sprints. And the idea is when you deliver P4, you have working software. It works. It doesn't do everything. It works. It does something. And then for P5, it does more. And for P6, it does more. And for P7, it does all of it. And all of that, when you deliver, say, P4, and you've only got a few things that are working, but if you selected those things to be tested, then they would actually be not just working, but you've actually run tests to verify that they work correctly. So this is how the agile software process works. You build things in these little segments called sprints. And at each sprint, you test what you're delivering. Now, in a real system, you would test everything. I'm only asking you to test a few things because, again, you're only one person. This is one class, one semester. It would be too much work to ask you to test everything. So I'm going to ask you basically to demonstrate that you know how to do testing. So that's the basic layout. P2 is going to be the description. P3 is going to be the design. P4 and 5 and 6 are basically nothing but code drops, and then 7 is the final code along with the documentation. And what documentation do we need? Well, if we look in the, what I have it here. If we look here, there's going to be the proposal, which you've already turned in. There's going to be a software design document, which you're going to turn in just the description for P2, and you're going to flesh it out with the design, the actual design in P3. But then there's also going to be this agile tracking sheet, which we'll talk about in a minute. This is basically your plan for how you're going to complete the project. And then a requirements and test document. So the requirements and test document is, we won't talk about this for a couple more weeks, but it's basically where you set up, okay, here's how I know that the software works. Here's the requirements, and here's the tests that I did to convince myself that those requirements were met. And we'll talk about that in a couple weeks. So there's basically, if we count the proposal, there's 1, 2, 3, 4 pieces of documentation that get put in there. The proposal, software design document, this agile tracking sheet, and the requirements and test document. The 4 documents in addition to your software. You never create software that's just software. There's always software with documentation. Now the documentation here is minimal. How long are these things going to be? Well, your software design document, I'm going to say, is going to be 4 pages, 5 pages total. Your requirements and test document, 3 to 5 pages total. And you're not writing it all at one time. You're writing it as the semester goes. Agile tracking sheets, 1 page, plus the cover page. So I'm not asking you to write 30 and 40 page reports here. Now, having said that, I have received 30 and 40 page reports from students in the past. That was just a whole bunch of information. Most of it was data type stuff. Questions so far? Okay, we'll talk about the software design document, and then I'll talk a little bit about the agile tracking sheet today, but next Friday we'll talk a lot more about the agile tracking sheet. I'll give you some examples. So where's the, let's see, here's the actual P2 assignment. Quite short. There's your rubric. Pay attention to these rubrics. So if you want to know how much something is worth and where I'm running short on time, what should I sacrifice? Look at what's the least amount of points. So you're going to have, in this case, 40 points total. And the description of the problem is fairly hefty. That's following the the fullness of the description, the accuracy of the description. Grammar and references is just a small amount. And then this agile tracking sheet, which we haven't talked about much at all yet, but we will. Okay, I give you templates for all this stuff. So, template for the software design document. Replace project title with your title. Replace student name with your name. Whatever the date is, that's fine. If you want to put a revision in there, that's fine. Rev 0, Rev 1, Rev 2, that's all. And then I tell you in here what to include. Now, there's 5 parts. Let's see, introduction, problem description, user stories, problem solution, references, and appendices if you need them. When you first turn this in, the problem solution here is going to be blank. Turn it in anyway. Turn it in with that section there. Don't just cut out that section. You can turn it in and say exactly this. Shall be delivered in your complete draft version for P3 deliverable by PP4. That's fine to just leave that in there, TBD. That's how you write documents. You write them as a shell and you leave the blank parts blank. You put a reminder to yourself to write that in later. And that's how we're going to end up writing software too. The user stories, you'll list them here, but you have a tracking sheet that does more than just list them. And the problem description is really the part that you're going to be dealing with. Talk about functionally what your software will do. You're trying to describe what it does, not how it does. That's the design part. So this is the biggest part of what you're going to do for the P2 deliverable. Introduction is just short. First thing the introduction should do right off the bat, in my opinion, you should always tell the reader what this document is doing, in this case, what your project is doing, and why. So I gave you this document for 2 reasons. One is I'm telling you what is this document doing for you? It's telling you how to write the report. It's telling you how to format the report. Why? So you get a better grade. And hopefully learn about technical writing along the way. So you're going to fill in the introduction, which is going to be more general. Oh, okay, some people are doing neural nets. And they're doing, one person is proposing doing neural net to recognize some handwritten characters. Okay, right off the bat, that's what that is. What is this project doing? It's going to develop a neural network to recognize hand-drawn characters. Why? Well, neural nets are really popular these days. Note, I just made a claim, should probably reference that. And it would be a good learning exercise for the student, for the author of the project. Or the author of the project maybe has some usage in mind further down the road. And this would be an initial step towards that. Just a brief thing. And then a little bit of background. Okay, maybe you should talk about in that instance, what is a neural net? Or what is machine learning? Just very briefly, top level. You kind of set the context. If you're doing some kind of a game, you might want to talk about the other games that are similar to it. Set the context, set the environment. Tell us what world we're in here. Is it the world of physics? You know, some people are doing particle physics simulators, interplanetary trajectory calculators, things like that. What world are you in? Who uses this? What community cares about this stuff? Just a couple of, that's 2 short paragraphs that go there. And then that's really general. It doesn't really talk much about what your project's doing. And then once you get into the actual problem description, now you're describing the project. Now, why didn't I call it project description? I call it problem description because you're setting up a problem for yourself. Your project is solving a problem. Even if you're playing a game, you're solving a problem. What's the problem? How do I get this stupid thing to play the game? So you describe there functionally what your project should be doing. And again, I've given you examples. I've given you examples of P2 deliverables in that zip file, good, average, and bad. And even, you know, we can nitpick even at the good ones. But the bad ones, I think it'll become clear to you how bad looks. And I think what we'll do next Friday, I want to go over the agile tracking sheet more, but we'll also spend some time talking about, okay, why is this bad? What's the right way to fix this thing? Okay, I'm pausing for questions again. Okay, so the next thing it's also due with P2, and you see it, I tell you when they're due, right? Completed by P2. So these and the agile tracking sheet, and these user stories are almost certainly a new term to you. By the way, you can look up Agile Scrum online and find lots and lots and lots of information about it. But I'm asking you to turn in the sheet, and it is literally a sheet. And I've given you the instructions with some example user stories. And what a user story is and we'll go over this again in more detail next Friday. But what a user story is, it's a specific piece of program functionality. And it's described as a user story, meaning as a user, I want something to happen. You know, here's a story, tell me what happens. And the framing is as a blank, I want to blank. And often it's as a blank, I want to blank in order to blank. So example, if I have a Space Invader-like video game, as a player, I want to be able to move my icon left and right, that kind of thing. So we're going to talk about that in more detail. But the idea behind the sheet here is you put your user story here. And then after you create your user story, you have to ask yourself, how do I know if this user story is done? How do I know that I've completed that one? And that's the completeness criteria. So it's not a formal test. It's not a requirements and test thing. It's a description that you can get a good warm fuzzy that this thing is completed. Then you enter in a priority, and it would be easiest once you create your user stories, and you might want to create them offline and then put them in this chart. Create your user stories, set up the priority, and then, and only then, put them in here so that you can prioritize them from highest priority to lowest. No. For me, a highest priority is always number one, but use whatever system makes sense for you, whatever you want. You might have to explain the system, but you know, you prioritize every user story. That you are not allowed to have ties. You cannot have two user stories with the same priority. They must be different, even if it's a completely arbitrary difference. And then you put in how long you think it's going to take to do that user story. And this should take 4 hours. This should take 8 hours. This should take 3 hours. Right? One of the reasons I'm having you give feedback on how long it's taking to do your homework, that's partly for my benefit so that I can make sure that the homeworks really are scoped in the way that I think they are in terms of effort. But it's partly for your benefit to get you to think, how long does it really take me to get a piece of software done? If I know that this user story is kind of like homework 3 and it took me 4 hours to do homework 3, I should probably put 4 hours in there for my effort estimate. Now, you know how much time we had here between these deliverables. Let's see. So I say, okay, between P3 and P4, you've got a week and a half. And I believe on the original chart, I said, okay, I think P4 should take you about 8 hours or 10 hours, something like that. So let's say you say, okay, between October 21 and November 2nd, I can probably work on this project for 10 hours, let's say. Then you can pick 10 hours worth of user story, and you say that's going to go in my first sprint. That's going to be in sprint 1. So then you would estimate here, okay, that's going to be in sprint 1, sprint 1, sprint 1. So that's what that is. It's just a plan. Now you're allowed halfway through, you're thinking, oh man, all my effort estimates I was way low. You're allowed to add to that. You're allowed to modify those. But it's an initial estimate. The idea here is you notice what's happening. We're trying to get planning. So that by the time you're actually coding, not only do you know what you're coding, but you should know how long it should take to code. And now you can track yourself. Okay, am I ahead? Am I behind? And then for each sprint, okay, here's what I'm going to work in this sprint. I'm going to do user story 1, 2, and 3. What was completed this sprint? I can't do that yet. When I turn in the next version of this for sprint 2, I can say, okay, now I completed 1 and 2, but I didn't complete 3. So I'm going to say 1 and 2 goes here and 3, 4, 5 goes here, something like that. And then in this bottom box, you're just tracking your progress. Now this is, the trick here is, this is not tracking how much time you have spent. This is tracking how much time you think you still need to spend. It's different. So if at the beginning, the example I put in here, if at the beginning of this, I did all my user stories, I did all my effort estimates, I think it's going to take 70 hours to get the job done. Okay, so at the very start, how much work is left? 70. And if all goes well, now I did these by week, so this is every week goes by. If all goes well, after 1 week, I'll have 60 hours left. After 1 week, I'll have 50 hours left, on and on and on, down to 0. That's my plan, and never change that. But then when you actually start, 70. And then you say, oh, wow, it doesn't matter how much time it took to complete the work. Look at what you have left to do. Oh, I'm doing pretty well. I only have 55 hours left to go. And maybe the next week wasn't so good. Oh, okay, I didn't do anything that week, so I still have 55 hours left to go. And the idea is you're going to count down, and when you're done here, you should also be at 0. It's a way for you to track your progress. If you're here and you had planned that you are supposed to have 30 hours left of work left and you're still at 60, that's a really strong clue that something isn't working right. You and I should talk, or you should figure out what's happening in your schedule that you can fix that. We'll go over this again next week, and it would be clever of me to have a completed example. I would like to do, I think I'm going to try to do the sheepdog game with examples. So if I have the ability next week, I'll fill out a P2 and a agile tracking sheet for the sheepdog game. Pausing for questions one last time. Okay, I will see you next week. Have a wonderful weekend.